Hey everyone, welcome back to the show for another deep dive. And today we are going to be taking a look at LM2 augmenting language models with memory
This is a fun one.
from Convergence Labs.
Yeah.
And this is an area
Yeah.
that I think is really, really interesting. The AI world is kind of obsessed
Yeah.
with this idea of long context and, how can we give AI
Remember memory, yeah.
this is a longer memory. So
Absolutely.
let's dive in and maybe you can just start by giving us a high level overview.
Yeah, sure. So basically the problem that they're trying to solve is that standard transformer models are really bad at long context. So if you give it like a really long input sequence, it's going to kind of forget what happened at the beginning. And, you can't really do much about that because the attention mechanism can only attend to a certain number of tokens. So what they're trying to do is they're trying to augment these language models with an external memory module so that it can store information that's important and then retrieve it later when it needs it.
Yeah, it's kind of like that classic needle in a haystack problem where you have all this information and you need to be able to pick out
They're right
little-
pieces, exactly. And they're trying to build like a separate module that remembers only the important stuff and forgets everything else.
So it's a decoder-only transformer model?
That's correct.
Am I understanding that right?
Yeah, so it's basically just the decoder part of the transformer. And they're using this memory to augment the decoder.
Okay, so can you break down how the memory module works? What's going on under the hood?
Okay, yeah. So the memory module is basically a memory bank. They call it a memory bank. And it consists of n memory slots. And each slot has dimension d, so it's kind of like a matrix. And each slot can store a vector of information. And the way it works is they use cross-attention to figure out which slots are important for given input. So they have like a query vector that comes from the input, and then they do cross-attention with all the memory slots. And then the slots that are most similar to the query, they get activated, and then they get read out, and then the information from those slots is used to augment the decoder.
So as it's processing the information, it's kind of figuring out what are the most important pieces and storing them in these dedicated slots.
Exactly.
How does it decide what to remember and what to forget?
Sure.
Sounds like that could get pretty messy if it's just storing everything.
Yeah, so that's where the gating mechanism comes in. So they have these three gates. They have a forget gate, an input gate, and an output gate. And the forget gate decides which information to forget from the memory. So if something is no longer relevant, it's going to get forgotten. And then the input gate decides what new information to add to the memory. And then the output gate decides which information to read out from the memory.
So those three gates really control the flow of information in and out of that memory bank.
Exactly. Yeah, it's like a control mechanism for the memory.
So we've got this idea of a memory bank. We have these gates that are controlling what goes in and out. But you mentioned cross-attention. Can you just kind of give us a little more detail on how that plays a role in selecting the right memories?
Yeah, so cross-attention is basically a way of measuring the similarity between two vectors. So you have a query vector and then you have a key vector and you calculate the dot product between them and that gives you a score. And then you use softmax to normalize the scores and that gives you like a probability distribution over the keys. And then you use that probability distribution to weight the values. So in this case, the query vector comes from the input and the key vectors come from the memory slots and the values are also the memory slots. So basically what it's doing is it's comparing the input to all the memory slots and then it's figuring out which slots are most similar to the input and then it's reading out the information from those slots.
So it's almost like a spotlight that's shining on the most relevant parts of the memory based on what it's processing in the current moment.
Yeah, it's like a soft attention mechanism that's focusing on the most relevant information.
So the model's not just switching back and forth between using its memory and using its regular transformer processing abilities. It's actually integrating these two things together.
Right. Yeah. So the information from the memory is used to augment the decoder. So it's like it's feeding the information from the memory into the decoder, and then the decoder uses that information to generate the output.
So it's kind of like having a detective who has this vast knowledge base that they can draw on, but they're also able to use their own reasoning and deduction skills.
Exactly. Yeah. It's like combining the best of both worlds.
So it's a very powerful architecture, it seems like.
Yeah.
But of course, the real test is how does it perform in practice?
Right. Yeah, that's the important part. So they tested it on a couple of benchmarks. One of them is called Babelong, and it's a long context language modeling benchmark. And they found that LM2 significantly outperforms other memory augmented language models. Like the previous state of the art was RMT, and LM2 gets like 37.1% better than RMT. And if you compare it to like a baseline transformer model like Llama 3.2, it gets like 86.3% better.
Wow, that's a huge...
That's a huge improvement. Yeah. And they also tested it on a more general language understanding benchmark called MMLU. And they found that it actually improves performance on MMLU as well. So it's not just good at long context, it's also good at general language understanding.
Yeah, sometimes when you have these models that are really good at one thing, it's almost like they
overfit, yeah.
overfit. Yeah,
They sacrifice performance on other tasks.
exactly.
But this one seems to be doing well on both.
So it's not just memorizing information, it's actually understanding it and able to apply it in different
Exactly.
Right.
Yeah, that's the key takeaway.
contexts.
Yeah.
That's fascinating. So I'm curious, we're talking about this memory bank, but what's actually being stored in there? What kind of information are we looking at?
Right. Yeah. So they use a tool called Neuron Explainer to kind of understand what's being stored in the memory. And they found that different memory slots seem to specialize in different types of information. So, for example, they found that one slot seems to be specialized in factual information and like question answering structures. So it's kind of like a mini knowledge base within the memory bank.
So it's not just random pieces of data,
Yeah.
it's actually organized
It's organized. Yeah.
in
Yeah.
the information in a way that makes sense.
Yeah.
Yes, that's slot 1679 that you're talking about. And then they also found another slot that was focused more on structural cues, so things like options and answer.
Yeah, so this slot seems to be picking up on the structure of the input. So it's like it's understanding the format of the input and it's using that information to better understand the content.
Oh, that's interesting. So like if you're giving it a multiple choice question, it's able to recognize,
Obviously.
okay, these are the
These are the options. These are the answers.
options, and this is where I need to pull the answer from.
Yeah, exactly.
So we have these different specialized slots. And then they also had one slot that was just kind of like a contrast. They said it had mostly negative activations, which means it wasn't really involved in this specific task.
Yeah, so this is slot 1, and it seems to be like a general purpose slot. It's not really specialized in anything.
And then one of the coolest things I thought was that the memory actually updates during testing.
Yeah.
So it's not just this static thing that's set at training time. It's actually able to adapt and change as it's processing new information.
Yeah, that's what's really interesting about this model is that the memory is dynamic. So as the model is processing new information, it's constantly updating its memory, and it's using the cross-attention mechanism to figure out which slots to update and how to update them.
And they show this really well in the paper with figure 6 with these cross-attention heat maps. And you can actually see how as the model is processing information, the attention is shifting to different memory slots and is pulling the information.
Yeah, you can see how the attention is like converging on the relevant slots. Yeah, and it's really cool to see how the model is like dynamically updating its memory.
So we have this model that can store vast amounts of information, reason, over a really long context. And it's even able to update its memory in real time. So it's really starting to feel like we're moving towards this idea of AI that can learn and adapt
Yeah, I think this is a really big step towards that goal.
in a much more human-like way.
Yeah, absolutely.
But what are the implications of this? You know, we've talked about all the technical details, but I
Yeah.
want to kind of step back and think about the bigger picture. Where can this technology lead us?
I think one area where this could be really impactful is scientific research.
Oh, yeah.
You know, imagine if you have a model that can read like all of the scientific papers that have ever been published.
Yeah.
And then it can remember everything.
Right.
And then it can like help you come up with new research ideas or like connect the dots between different papers.
Yeah, it could help you see those connections that you as a human researcher might just
Yeah.
miss because there's just too much
Too much information.
out there.
Yeah.
Yeah, and that kind of leads into education as well. Like imagine if you had a
Oh, yeah. Personalized education.
personalized tutor
Yeah.
that could remember everything you've ever learned
Yeah.
and tailor its lessons to exactly what you need.
Yeah, that would be amazing.
Yeah.
Like, imagine a model that knows your strengths and weaknesses.
Yeah.
And it can like adapt the curriculum to your specific needs.
It could even adapt its teaching style to, you know, if you're a visual learner or if you're more auditory.
Yeah.
It's crazy to think about. And then, of course, healthcare is another area where this could be really transformative.
Oh, yeah, absolutely.
Like, imagine a diagnostic tool that can access your entire medical history and all of the latest research and give you a much more accurate diagnosis.
Yeah. It could even predict potential health problems before they even arise.
Wow.
Yeah.
That's amazing.
Yeah. And it could help with drug discovery.
Yeah.
You know, finding new drugs that are more effective
Right.
and have fewer side effects.
It feels like we're almost getting into science fiction territory here. But it's really not that
I know, it's crazy to think about.
far off.
But it's not just about these practical applications.
Yeah.
You know, it could also be really interesting for creative fields.
Oh, yeah. Tell me more about that.
Like, imagine a writing assistant that can help you write a novel or a screenplay
Yeah.
or compose music.
It could remember all the characters you've created and the plot points, and
Exactly.
Yeah.
Yeah, it could keep track of all the details.
it could help you stay consistent.
And it could even suggest new ideas or plot twists.
Yeah, that would be amazing.
It's really exciting to think about all the possibilities.
It is exciting.
Yeah.
But I think it's also important to acknowledge that there are some potential risks and challenges with this kind of technology as well.
Oh, yeah, for sure.
I mean, one thing that comes to mind is bias.
Mhm.
You know, if these models are trained on biased data, then they're going to reflect those biases in their output.
Yeah, that's a really important point. We need to be very careful about the data that we use to train these models.
Yep.
And we need to make sure that it's diverse and representative.
And then another challenge is interpretability.
Yeah.
These models are becoming so complex that it's hard to understand how they're making their decisions.
Yeah. That's a big problem, especially in fields like healthcare, where you need to be able to trust the model's output.
Exactly.
So we need to develop new techniques for making these models more interpretable.
Yeah, I think transparency is going to be crucial if we want people to trust and adopt this technology.
Absolutely.
So while there are definitely some challenges to overcome, the potential benefits of LM2 are just incredible.
Yeah. I'm really excited to see where this research goes in the future.
Me too. It feels like we're on the cusp of a major breakthrough in AI. And who knows, maybe someday we'll have AI that can truly learn and think like humans.
Yeah, that would be amazing.
Well, this has been a fascinating discussion. Thank you so much for joining me today.
Thanks for having me.
It's been a pleasure.
Yeah.
And to all of our listeners out there, thanks for tuning in to another Deep Dive. We'll see you next time.